Hey everyone, welcome back to SimCron. This week I am delighted to present Mr. Sandro Gauci. If you don't know Sandro, you will know Sipvicious, but suspend your rage. He's a really, really nice guy. I've seen him present at multiple conferences and I love the story, and we thought we'd share it with you here. So Sandro, welcome.
Hi, Simon. Thanks for welcoming me and thanks for the introduction.
That's right. So first question, give us your background. How did you get into security? Are you a SIP guy that found security, or are you a security guy that found SIP?
Well, I'm not sure how to answer the second question, but because it's a bit of a combination of both, I suppose. But yeah, I mean, as a teenager, I had no idea that security could be a professional job, or simulating hacking attacks in reality, pen testing. So as a teenager, I thought, yeah, I like things like graphics and so on. And so I thought, yeah, I would want to focus on graphic design and so on. Nothing to do with security at all. But on the side, I had this interest in the hacking community. I was fascinated by stories of people like Captain Crunch, the phone freak, and Kevin Mitnick, doing both phone freaking and later on hacking and social engineering attacks. I was on this side, well, a bit too. During the late hours, I was reading text files from hacking groups like the CTC, Cult of the Dead Cow, from years back. We're talking about 20 years ago, okay? So this was an interest of mine, and of course I was trying things out, which I won't delve into too much. But yeah, as an 18-year-old, I was thinking, should I go to university, or what can I do with my life? I was hanging around IRC a lot. I was on a channel called Hash Malta. I'm from Malta originally, and someone was actually asking for someone with an interest in security and hacking. He seemed serious, but I was very skeptic, of course, and very wary. Anyway, I messaged him, and eventually I had an interview with a company called GFI. They used to provide fax software back then, but they wanted to. They saw the future. They saw the market. They wanted to get into security, and this guy who was on IRC ended up being my manager, David Vella. Hello, it's been a while. And yeah, they hired me as a security engineer, which pissed off the real engineers because I didn't even go to university. So I preferred to call myself a security researcher, which I still do, to avoid conflict. And yeah, I was doing security testing of GFI's internal software, and they are a vendor, so they were developing security software for email and security software for network security. So I was testing that for security issues. I was testing third-party software like Microsoft's Internet Explorer to understand what security issues we have to protect our clients from. And I did, in fact, publish some security issues in Microsoft MSIE back in the days when it was really easy to exploit some of the buffer overflows and so on. Unlike today, it's a bit different. Yeah, and it was fun. I did this for another 5 years and then switched to another company. They did credit card related stuff. I was their security analyst. Eventually, I started my own company and started more like freelancing.
Yeah.
pen testing. I had been pen testing in the past as well. So yeah, that's when I started Enable Security with a bit of a focus on voice over IP, but I did everything from web application security to internal network security, pen testing. Okay, it's always about simulation of hacker attacks. Yeah.
And then Sipvicious presumably came out of that.
Actually, Sipvicious came out a year before I started officially started pen testing as a freelancer, as Enable Security. So Sipvicious came out in 2007. I was doing a pen test on a PBX for the PBX vendor. I won't name any names, but the developers were very, very skeptic of the security findings that I had. Unfortunately, back then, the software that existed was mostly proof of concept. There was one main book about pen testing voice over IP, the Hacking Exposed book, which had some code, but it was hard to convince people, hey, you really need to fix this because weak passwords are so easy to brute force. I knew they would be so easy to brute force because this was UDP. You could just send a barricade of UDP packets, challenged response, and so on. It can go really quickly, but the tools were really slow. So yeah, I had that problem. So I started writing some Python code. I loved Python, and yeah, and it worked. The client did fix their problems. I shared some of this code with colleagues who were actually testing PBXs on internal networks, which were mostly based on Asterisk, I think. And they found them useful. They contributed back by, telling me how much my code sucked, but it could be improved with bug fixes. So eventually, after a couple of iterations, I published Sipvicious. It became Sipvicious, and there were 3 tools: as VMap for scanning the internet and scanning the networks for discovering SIP devices, as VWAR for SIP enumeration and extension enumeration, and as VCrack for password cracking, online password cracking. And together they could be used, really effectively on a large number of PBX installations. So that was effective. But yeah, of course, there was a lot of abuse. So eventually, the cybercrime people started making use of Sipvicious for their own ends and purposes. I had done a presentation at Camellia World in 2016 about this. I went into some detail. But yeah, essentially, the worst case scenario was which actually happened, was when Sipvicious got distributed through a botnet, through a Windows botnet. And this Windows botnet was attacking, PBXs on the internet, essentially.
Yeah.
And this caused denial of service for a number of vendors and so on. I think that was the Sality botnet. It was not good. What I tried to do was I created a new tool called svcrash, which crashed Sipvicious. There was an unhandled exception, and we could exploit that to get it to stop. It was relatively effective for some people, but of course, this is just playing games, right?
So we've all seen it. I think and I've spoken about fraud loads before, as you know, but I think my record in testing is about 5 minutes for a newly deployed previously, unused IP address to see a scan. I mean, it's crazy the scale of it out there. But yeah, it's generally unmodified, same as the other tools that they're these guys are using. But even what are we, 13 years later, it's still absolutely massive, isn't it?
Yeah, so you still see a lot of scanning being done with Sipvicious. However, nowadays there are some other tools that are also being used, and you can see they're scanning them using this for scanning. There's one particular tool that is doing SQL injection. I really don't know how effective it is, to be honest with you. But I do see that when just sniffing on port 5060 on one of our systems. And yeah, you see other tools as well.
And I remember your 2016 presentation really, really well, because I don't think we'd met before then, but obviously I talked about how evil Sipvicious was and all the harm it was causing, and I really felt for you after that presentation, because you never had bad intent when you put it out there. Quite the opposite. But I remember you talking about getting phone calls at 3 o'clock in the morning from Egyptians wanting to give you money and things like that. I mean, presumably, does that sort of thing still go on, or has it calmed down a bit?
It does from time to time, especially whenever I publish a new blog post saying that we have a new version of Sipvicious Pro, which we don't make available outside our client set of clients.
I want to talk to you about that in a bit.
Yeah. So it does happen. I don't get these phone calls anymore, but I also we don't really publish our phone numbers too well. So we're not very good with receiving phone calls. Even we're good with email. But yeah, even on my personal Skype account, I often get new people adding me, and then I check out who they are, and I find out that they are probably from a certain region in the world that is well known for VoIP hacking.
Yeah.
So yeah, it's weird.
But you're still very, very active in the security space, particularly RTC security. And I know we've had a couple of conversations this year where you found vulnerabilities in quite well-known products. So Jitsi Meet and Camelio being the two that spring to mind that you kindly gave us the heads up about. Have you got anything you can show us today?
I do, yeah.
Fantastic.
So yeah, we've got. I wanted to speak about WebRTC security a bit. I think WebRTC has really become really useful all of a sudden, as everyone needs to work from home, and security has been there from the start for WebRTC. So unlike SIP, where security a lot of it is kind of patchwork. There are RFCs that try to focus on security and SIP, but I don't get a good impression on SIP in general. WebRTC, on the other hand, you've got some basics covered. You have it mandates the use of secure signaling. So signaling has to happen over some sort of TLS connection, and also you need to use SRTP with the TLS for the key exchange. So that's pretty cool. And so you do see people talking about WebRTC as if, okay, this is a really secure thing. But of course, like anything else, I don't think so. Look, the thing is, WebRTC is huge, right? There's so many different protocols involved. So the code base is huge for the WebRTC web browser stack. And not only that, you have WebRTC infrastructure, which needs to be server side, that likely has some sort of security issues, right? And so you have all these different protocols. You have the TLS, we mentioned it. We have RTP or SRTP. You have the signaling protocol, which is maybe custom.
Yeah.
And if it's custom, that means that it likely implements a subset of SIP in some other way in JSON, probably. So you might have the similar security issues that you see on SIP.
Yeah.
On this, or you might have SIP over WebSocket used for the signaling.
Yeah.
Where you're back to square one. You allow us to test or to exploit SIP vulnerabilities or SIP related vulnerabilities over WebSocket on the server side, on the infrastructure. There's turn servers, which we found out by default, at least Coturn used to be relatively insecure. Now they've made code changes so that they closed these security issues. But we found this security issue that we like to call the open turn relay vulnerability, that we found it on affecting different providers, different service providers, one of which was Slack. Before Slack, we found it on our clients as well, on our private clients years back. And Slack had the bug bounty, so we submitted that through the bug bounty, and eventually we made it public, like recently this year. And yeah, I can demo that because we have a demo server to show this off.
That'd be great, yeah.
So I should share my screen. All right. And now,
there we go.
Can you see my screen?
I can.
So we have a demo server, demo.sipvicious.pro. Anyone can use this, actually. It's based on Nginx. We have Camelio there, we have Asterisk, and Coturn. And for this demo, so we use this to test Sipvicious, Sipvicious Pro, Sipvicious the open source as well, and other tools for.
So this is an interface to a test against your own instances of those particular servers.
This is a target server. Okay.
But this is the web interface that we're looking at here.
Now we're gonna look at a web interface, yeah.
Okay.
So we have /call, which is right now it's hidden, but we will be exposing it. Anyone watching this video can go there.
Okay.
I'm gonna start the dev tools, and in the dev tools we have a plugin called WebRTC Reaper, which my colleague Alfred wrote. Let me refresh that. And the page says, shall we play a game? It might be familiar to some old school people. You can play chess and poker, but those are not really. And there's the other biotoxic and chemical warfare, which we did not really implement yet, but we did implement performing a call.
Okay. So
if we perform a call, this is gonna be using WebRTC. The call, we don't need to get this call actually, so I'm going to disconnect. And what's happening is when setting up the call, the WebRTC part of the web browser is doing guys candidates, so trying to find out how to pass RTP. And one of the ways to pass RTP, well, the last resort really is to pass it through a turn server to proxy the RTP in case when a direct RTP stream cannot be established. So we get there are what the browser gets is a turn server address and the username and password, right? Or a couple of addresses really, but yeah. So the plugin makes it really easy for us to just copy and paste the address and the whole command actually that we want to run, so that we can then use a tool which we call Stunner to abuse this proxy, this turn open relay vulnerability. So the turn open relay vulnerability basically is abuse of the turn server to connect to internal IP addresses, because that's what turn servers anyway do. They allow you to connect to other hosts. So we use it to connect to internal IP addresses. We use it to connect to, for example, if the server is hosted on AWS, we might connect to the AWS meta service and get some temporary credentials that might, in some cases, lead to a major compromise of the AWS infrastructure. But in this case, I'm just going to show that there is a secret page on the demo server. Can go on HTTPS as well. /secret, which returns a 403. Now this page is configured to only allow localhost connections. Otherwise, it gives us the 403, right? But by abusing the turn server, which is on the same web server, we can get the turn server to connect us to 127.0.0.1, which I'm going to do. So I should probably start Stunner. So the username and password is user and Joshua, and this is the address of the turn server. Started the Stunner, and then if I go to this screen, I can start Firefox. I'm gonna show that from Firefox I also get the same screen, and if I go to localhost, of course I'm gonna get unable to connect because that's my localhost. But I'm using Foxy Proxy plugin to proxy easily, and I can use the Stunner SOX server that tunnels, that creates a SOX server to tunnel through the turn server. And once I set that up, if this works, okay, it doesn't like the HTTPS certificate because it does not match, but that's fine.
But it's still connected, yeah.
We get to connect to a page which shows us the secret page. And Simon, what do you do when you see a red button?
You should never push it.
Well, let's do that, yeah. So we push that, and we get to shut down everything. So terrible demo. But you know, this is how the turn server can be abused. Of course, what we saw was when we first discovered this on our clients, we saw internal Jenkins servers without asking for credentials and so on. Yeah. So it can be quite bad. It depends on the case.
If you think of where turn servers are generally deployed, that's quite a powerful jump-off point, isn't it?
It is. It is. So we did see cases where this was not a big deal as well, like in the case of the Signal app, for example. They
Yeah.
also had this sort of issue, but they explained that it's they reduced their risk so much they didn't allow connections to well, they had a separate server and so on, something like that.
Yeah, I guess if the
That it
return
wasn't
server
a
is
big deal in that
isolated in
case.
itself, there's nothing to jump off
Exactly.
to, even though you can jump off.
Exactly. All right. So that was my
That's
demo
presumably
for.
patched in the in current versions.
So let me switch that off. Okay. So current versions have. Yeah. So the current versions of Cotern, which everyone seems to be using anyway. There are some other turn servers as well. But current versions of Cotern don't allow local host connections anymore. And they are blocking certain addresses. I'm not 100% sure if you still need to do the full deny list that we have provided on our blog.
Right.
On our blog, we have provided a deny list where
like
you
RFC
can
1918 addresses, presumably.
exactly,
Yeah.
exactly. Which in some cases, because of a bug in Cotern, could block certain setups. So we had to amend to make a note, hey, there was a problem. But anyway, that's how it goes.
Brilliant. No, thank you for that. What else is occurring?
So yeah. So what else? Well, we can move on to Sipvicious Pro if you like. I can explain the differences and so on.
Yeah. I mean, you very kindly sent me an early version of that, and I love the look of it. But I'm guessing you've done a fair bit more work on it since then.
We have. So one of the things that we have been working on is making it easy to integrate Sipvicious Pro with continuous integration pipelines.
Yeah.
So Sipvicious Pro is very, very different from the open source version. So the code has nothing to do with the old code. It's a complete new rewrite. We don't implement all the features that we had previously, but we implement a lot of new features and a lot of features that we actually use in our pen tests. So it's rewritten in Go, not distributed as open source. We don't really have plans for open sourcing it.
I can imagine.
Yep, after what's happened in the past. And also, we put a lot of effort into this. So we'd like to, license this to our clients, which we already started slowly. It's aimed at service providers and vendors. So we're not,
Yeah.
we haven't been focusing so much on other pen testers. But of course, we are the primary users of this tool. So we are pen testers, so it is definitely pen tester friendly.
Mm.
It has support for more than SIP protocols. So we talk also RTP. The SIP implementations, they do proper SIP. So unless the tool requires that SIP gets broken. And we focus a lot on the denial of service tests because this is such a huge deal. We have an internal library for making network connections really fast. while still maintaining a certain logic or SIP sessions, which can get a bit complex. So we can really do fast attacks without having a huge penalty on different protocols that are supported with SIP. So we support UDP, TCP, TLS, WebSocket, and Secure WebSocket. And it's all the same. You just specify the target. In the target part, you specify what protocol you want. It's a URI. So TLS : target : port. And there's a couple of slashes that I forgot. And kind of we do support WebRTC protocols to a certain extent, especially because there are some cases where you see SIP over WebSocket, and we support the TLS SRTP, apart from SDS, of course, but that's not part of the WebRTC. So, yep. Do you have any questions about?
Yeah, I mean, when I looked at it, I mean, apart from the fact it's written in Go, I love Go. I can't write it, but it's one of those languages. If ever I get time, I would love to, I would love to learn to use. It's just really impressive, the whole model, and it's kind of scary to think of the kind of denial of service opportunities it would present you just for its sheer efficiency. But the other thing that I loved with Sipvicious Pro was the exit codes from tests, which makes it perfect for CICD. And you say you've been working on that, which is really interesting. You got anything to show us in that respect?
Yep.
Fantastic.
So I have some demos to show. I can share my screen again. Let's see where that is. Here. And can you see the screen now?
Yep.
Okay. So we have our internal GitLab over here. And we have an asterisk configuration repository. And basically, I should show the different files. So what I should start with is the GitLab CI. So we have the GitLab CI tells you what image to use, and we have a custom image for this case. Why do we do this? Because perhaps the vendor or the service provider using this sort of system needs to compile their asterisk in a certain way, and also it makes it easy to include the Sipvicious tool inside the image without having to, copy it every time and so on and so forth.
Yeah.
So I can show that how that works. The Docker file. It's essentially an Ubuntu base image. Downloads asterisk, compiles it, make install, and in the end copies Sipvicious, and you have your very nice container. Now, if I go back to the GitLab CI, we can see that we have two stages. Okay, first there's the test stage, and then there's the deploy stage. The deploy stage is it's a gimmick. It's a mock-up, just to show that the test phase, if that fails, you don't get deployment.
Yeah.
So now I can show what the test phase does before moving on to the actual demo. So the test phase simply, well, we use the set pipe fail and so on, so that whenever a command fails, it exits. And first it copies the configuration to the asterisk location, starts asterisk, and then now the configuration is what we will be editing, of course, what the developers would be editing. then waits for asterisk to start. We're using netcat, checking the PID of asterisk. And then it runs Sipvicious SIP and enumerate methods, in this case, just as an example, which is basically sending various SIP messages, all with different SIP methods that Sipvicious supports. So it first sends register, then sends invite, and so on and so forth, and checks if any of them result in an authentication bypass. Because sometimes you might not be authenticating certain types of SIP methods. So that could be an issue. So if
That's
we go
so
back,
powerful for a single line command.
yeah, and of course, what we imagine is that our clients would be using various different attacks, and each attack has various different options. So there's a lot of tests that can be done using this method. So I can go to the configuration and just make a small change to introduce a security issue. So in this case, I'm going to introduce the anonymous endpoint in asterisk PJSIP channel. And what this does is it allows incoming invite messages to and message SIP methods as well to be done without authentication. Now I'm going to show what's happening in the job. So first it did what we saw before, deletes the configuration, copies the new configuration, and asterisk is started. And then it actually runs Sipvicious, which fails. So it identifies that the message SIP method as well as the invite SIP method, they both had a 200 or 202 return code, which is a problem. We have an exception for options, of course, but otherwise, yeah, this could be a problem in some cases. Of course, it depends on your setup.
Yeah.
But this makes it very easy, to if you run a certain number of tests, whenever you make a configuration change, it makes it very easy to run these tests again and again.
Yeah, I can think of several instances over the last couple of decades that I'd have really appreciated that.
You should start using it then. So I'm gonna make the revert it back the change. And so it's running. And this should succeed. So it's run. Sipvicious didn't complain because the exit code was
clean.
What was it? Was 0. And then what happens is you get a deployment, which is taking longer than the actual. Yeah. So deployment goes through, while before, when there was a problem, the deployment was stopped, of course, was skipped. Now that's asterisk. I have a similar demo, but it is a slightly more complex. We run 2 tests in this case for Camelio.
Okay.
So same thing. We have an image. I'm not going to show this time because it's exactly the same. What I'm going to show is run.sh. So run.sh does a very similar thing. It copies the Camelio configuration and waits for Camelio to come up, and then it does the same test, and then it does an additional test, enumerate extensions.
Okay.
Now, the SIP methods, we already explained what it does. This enumerate extensions is the typical attack that is done using the traditional Sipvicious, open source Sipvicious as well. In this case, we're doing it on TCP. So that's something that the open source Sipvicious cannot do, unfortunately, because of its design limitations. Anyway, and so I can show how this can be introduced. Now I have a Camelio CFG here. This is a really, really simple and I'm not sure how realistic as a configuration it is, but we found it useful to just demonstrate this without making really complex stuff, which you can with Camelio. We've seen some amazing complex things happening there. So I'll just explain it very briefly. If the method is register, and if it is an allowed extension, and we have a regular expression here telling us which extensions are allowed. Okay. It's 1100, 1200, and so on. So if you have those two, and then you have a particular header, and that particular header has a secret, then it returns 200. We're never going to see that, but the thing is, if that header is not present, then it sends a 404. And if the extension is not allowed, it also sends a 404. Now that's all well and good. And I should probably show you that the previous pipelines did not fail. I mean, the last pipeline did not fail.
The asterisk one, yeah.
Yeah. So this succeeded. Sipvicious did not complain about it. But if we change the reason, if we change the code, it's going to introduce an extension enumeration, a way to enumerate extensions. But also, if you change the reason, say by having a lowercase n, while the other one is an uppercase n, then it's going to create a way for Sipvicious and I suppose other tools to distinguish between an extension that exists, at least in this configuration, and one that does not.
Okay.
So I'm going to commit that change. And then we can go and check out what's happening.
Am I reading that right? Your allowed extensions is not defined, is it? Isn't that commented out?
It is defined, yes.
I thought it was commented out. Okay.
Oh, it's a define. Yeah. Should be fine.
Okay. Probably just me reading it wrong.
Yep. So let's get it. So it failed, and let's see what actually happened there. So it ran the same test as before, but then it did the extension enumeration test. And it found that the response phrase is not found, and it could distinguish between the two cases because of the uppercase and lowercase. But it could be just a different reason phrase. Of course, we've seen that. While the response code might be still the same. And thanks to that, Sipvicious could find out, okay, there are the following extensions that are allowed, and we can do enumeration. So this is a very simple mistake that could happen easily. I mean, this Camelio configuration, of course, it's very much inspired from what we've seen in with our clients. So it's not just something that we invented.
Yeah. I remember the old asterisk one where you get a 404 to an options request or a 200 OK, depending on whether the user actually existed, which
which was complying to the RFC. So
that was a very lightweight way of differentiating whether there was a user there or not. And a vector that completely sailed through fail to ban and things like that.
Mm-hmm.
That we're looking for registrations. That's amazing, and the obviously you just changed the reason there, but presumably you're looking at other headers as well to determine differences.
Not right now. So right now we are only looking at the reason, but that is
Okay.
another way. We did find that with our clients as well, just manually, but we did not yet implement that in our tools.
Right. Okay.
But it's definitely a concern. Yeah.
Yeah.
So it's
Certainly
something
feasible.
that we need to add, and it's on our to-do list. Just
Yeah.
there's a lot of stuff to be done.
Yeah.
So,
I just love that, and I can see the power of it so much in integrating it with build pipelines.
mm-hmm.
That's incredible, and presumably that's what your typical clients for this are doing.
Yeah. So we don't have anyone using this on their CI. We have discussed it, but yeah, we're very interested in having such clients. So that is something that we're looking into. We just, this is only just in the past few months that we started exploring this venue, and it makes a lot of sense.
Yeah, it really, really, really does. It just what's the sort of breadth of test you've got in there? You've shown us a couple of simple ones, but I know there's a lot more in it than that.
Yeah, so I can share my screen again. So if we go to support.sipvicious.pro, you can see the various tools that we have implemented. Each tool, of course, has a number of options and so on. So each tool can have different tests. So we have 3 RTP related attacks. We have, what do we have? 1, 2, we have a couple of SIP attacks. That's, yeah. And then once you couple that with making use of templates, which can get quite complex, then yeah, you can do a lot of stuff, which is interesting for pen testers, but also, of course, developers who want to try things out quickly.
Yeah.
Cross-site scripting through injected through SIP, for example. We give a few examples of things that we have done in the past.
Yeah. That's phenomenal. And if anybody watching this is interested in it, you've put the Sipvicious.pro address up there. Presumably they head on over there, have a look, and get in touch with you through the site.
Yep.
Fantastic. And I mean, a sort of slightly crude question, I guess. This is this is one part of how you make a living. What's the other part? Presumably people can engage you for pen testing and specific projects.
Sure. So our main offer is pen testing. We focus on real-time communication security, but what we do on a day-to-day basis is penetration testing of WebRTC infrastructure and voice over IP. So our 2 main types of clients are essentially vendors and service providers.
Yeah. Fantastic. Which is exactly our audience, or certainly the Simwood customer base. I'm sure you can help. Well, all of them. Final question. I think this is probably an easy one for you. Bug bounties. It's I'm interested in your opinion on them. It's been 6-9 months since Simwood first made one available, and it's been quite an education for us, and we've been quite surprised at the response. As a security analyst, are these something you value, look for, welcome?
Well, I have mixed feelings about bug bounties. So on the one hand, it's great to be able to to test at your own time targets that are juicy and interesting. Um, so from that aspect, it's pretty cool. On the other hand, it can be quite frustrating and difficult for the security person to focus. There is so much competition. Okay, so the public bug bounties are very hard. Even professional bug bounty hunters, which we're not, we don't focus on this so much. Even they admit that the public bug bounties are difficult to get anything out of, simply because there is so much competition, and so all the low-hanging fruit is basically immediately someone gets lucky and discovers it.
Yeah.
And the world is a huge world. There's a lot of people testing and checking uh, Google's infrastructure and so on and applications. On the other hand, if you want to focus on specific vulnerabilities, then that can cost you a lot of time, which is unpaid, right?
Yeah.
So it's a bug bounty. The risk is on the bug bounty hunter, and therefore it's not easy. For us, what we realized is, so we did some bug bounties a couple of months ago. We had some free time for that. Um, and what we realized was that we should just focus on the vulnerabilities that we have the best expertise on, that um, affect various different vendors. So we ended up looking at essentially the turn abuse vulnerability and hit a large number of vendors, uh, service providers, sorry, that were on bug bounties, on bug bounty lists. And that was fine. But when we tried to focus, just do 1 week or 2 weeks on one particular service provider, um, that's tough. That's
Yeah.
tough because you have to really watch out that you don't create problems for them. So you have to watch out for, doing mistakes which can lead to denial of service. You're not in a safe environment, right? So it's a live environment. You're not testing on staging. When we're doing pen testing, we have the help of our clients. We're testing on environments that can be tested, that have we know we have internal information, so we know what to focus on, and so on and so forth. And we're getting paid for it, even if we don't find anything, which almost never happens. Okay, but yeah, at least you're not taking financial risk as a
Yeah.
tester. Of course, living in Germany, like myself, is expensive, but living in other parts of the world, it's much cheaper. And if you get paid 2K a month from a bug bounty, that's perhaps okay. For
Yeah.
us, it's definitely, I'm not gonna pay my rent that way and cannot pay Alfred, my colleague, that way. So yeah,
Yeah.
it's
Yeah.
difficult.
That's really interesting. I think you hold the record for the biggest one we've paid out so far, and that was the Camelio issue you found, which we weren't vulnerable to, but but it was certainly a worthy
Thanks for that.
find. But we get literally dozens a day from a certain part of the world.
I can imagine which part.
Where I can only imagine that kids are sent home from school, almost homework, go and go and find a vulnerability somewhere. If you can get paid on out of a bug bounty, you'll get extra points. So a lot of them are at a very low and irrelevant kind of level, and a just operational overhead to process. But it's really welcome for us just to have that level of scrutiny on the platform, and that to be an avenue for somebody serious with a genuine issue to get it through to us, because prior to that we really just relied on obviously our own testing, but also relationships, guys like you in the community that would give us the heads up if they'd found something with something they knew we used, or something specific for us. So I totally understand where you're coming from, and it's an operational overhead our side, but I think probably on balance that they're a good thing, I think. But one challenge we have is when somebody sends something in, and it may be not a vulnerability, but theoretically imperfect, let's say in a web server configuration or something. What do you pay them? And I guess from your point of view, from the bounty hunter's perspective, that could be 10 quid. It could be, £1,000. It could be nothing. So you're putting your complete faith in the person that you're reporting it to, that they're gonna do the right thing. But anyway, I'm waffling now. So
That's fine.
Sandro, I really enjoyed that. That was tremendous. I'm sure everybody watching will appreciate. Hopefully, if they will, they'll click the thumbs up button. If you really didn't like it, click it twice. But otherwise, click the big red subscribe button. Sandro, thanks very much for your time.
Thank you, Simon.
We'll see you soon.
It's a pleasure.